Example 2 repeats exactly what we did in example 1, so I would advise you to pause the video right here and try to find the average rate of change. The only difference in this problem is that instead of x squared, we have x cubed as the function. So pause it here and see if you can get at least the first one done correctly. So again, what I want to do here is make sure to label things. Since 1 showed up first, I'm going to call it x1. Since 4 showed up next, I'm going to call it x2. The next thing I'm going to do is evaluate the f of x1 and the f of x2. So I'm going to plug in each one of those numbers, 1 and 4, into the original expression, which was x to the power of 3. And 1 cubed is going to be 1, 4 cubed is going to be 64. So now the average rate of change is going to be given by the fraction f of x2 minus f of x1 divided by x2 minus x1. This is literally the rise over the run. This is y2 minus y1 over x2 minus x1. So the y of the second point was 64, y of the first point was 1, divided by the x of the second point, which was 4, minus x of the first point, which is 1. So this is 63 divided by 3, which I believe is 21 at the end. So that's very straightforward. That's it. So 1 goes into the x1, and as a result, we get a 1. And that's what goes right there. And the corresponding 1 goes underneath it. Similarly, the 4 goes into the x2, and as a result, we get the 64. So the 64 gets placed on the numerator, and the 4 gets placed on the denominator. And then we just subtract all the numbers, and we're basically finished. Okay, so for part 2, the x1 is 1, and the x2 is 2. So 1 cubed is going to be 1, and 2 cubed is going to be 8. And then again, I do 8 minus 1 divided by 2 minus 1. So this is 7 divided by 1, which is at the end just simply 7. I hope you got the right answers. So again, pause the video here and see if you can do part 3, which is very similar to what we just did. So the difference is your x1 is the number 1 and your x2 is going to be 1.2. So it's just a little bit uglier, but it's exactly the same kind of math. Okay, did you end up with 3.64 for the last one? I hope you did. It's, again, very straightforward. You just plug in 1.2 and plug in 1. So although the problem wasn't very difficult, all we did was plug in a bunch of numbers. As a matter of fact, we can make it actually easier and faster by using something called the difference quotient. If you notice on the last 3 problems that we did, all the 3 parts had the same x1. They all had 1, 1, and 1. So the idea is if we can find a formula that predicts what we're plugging in and the difference between the 2 numbers, so like right here the difference was 3, right here the difference was 1, right here the difference was 0.2. If we can find a formula that uses the starting point and the difference 3 to get the 21 in one step, why not? That would be way easier, way faster. And that's the idea behind what you have on this difference quotient. So this difference quotient basically evaluates the slope of the line again, except it uses something a little bit different. It uses the starting point and the difference between the numbers to give you the final answer in one single step. So instead of evaluating the 1 cubed, the 1.2 cubed, then taking the numbers, subtracting them, dividing by 1.2 minus 1, and doing multiple divisions, the formula for the difference quotient is supposed to do all that work for you, and it spits out the answer 3.64 in virtually no time whatsoever. And the nice thing about this difference quotient formula is that it can be used multiple times as long as your starting point is always the same. You can plug in any difference you want and you get the answers right away. So it costs you a little bit of time at the beginning to just find the formula, but once you have the formula, plugging in becomes very simple. It becomes very intuitive to plug in numbers and the difference between the 2 numbers to get the final answer. So I'm going to show you how to do that in the next page. We'll do that in another video.